Respected viewers, today we will have a look at analog to digital converters. And in this lecture, we will just have a look at the basics of analog to digital converters. Now, what is analog to digital conversion and actually why it is required? Well, the analog to digital converters basically use the interface, the naturally available signals to the digital computing systems. Now, suppose you want to record somebody's voice into a digital system. A digital system means a computer, a laptop, a mobile phone. Then you will have to somehow convert the available natural sound or the analog sound into its counter digital part. So, in order to do that, the analog to digital converter plays the interface between them. Well, now let's have a look at the basic internal structure of a analog to digital converter. Now, what are the basic components here? First of all, there is a comparator, which is usually you can see an operational amplifier connected in open loop configuration. It basically acts as a comparator. Then we have digital to analog converter, which is this section, which actually gets the equivalent analog or the corresponding digital inputs provided into it. Then we have a register. This is a register. And we have the control unit. Now the control unit is actually provided with some input signals like start or the start of conversion input. Then we have the clock inputs and we have the end of conversion. So whenever a digital analog to digital converter finishes the conversion part of it, it will generate an end of conversion. Well, now let's have a look at the basic working of the ADC. In the initial stages, if you want to make the ADC work, you will have to first issue start of conversion command, and it is given to the control unit. Once we provide the start of command, a rate at which the clock is getting into the control unit, it will try to modify the bits available in the register. Now there is a unknown voltage which is available at VA. We will have to somehow get the corresponding output or the corresponding digital result at the output. So in order to do that, when we apply a start of signal or a start of conversion to the control unit, there is a clock which is provided into this control unit which will trigger this register, and it will try to change the binary number stored in the register. That binary number which is stored in the register will be directly coupled to the digital to analog converter. Now, the digital to analog converter's output will be proportional to the applied digital input. Now, this output of the digital to analog converter, which is VAX, is continuously compared with the input unknown voltage. Now, the comparator will continuously compare with the analog input voltage as long as the output of the digital to analog converter is less than VA. The comparator output stays high. So, when the comparator output stays high, the control unit will keep converting the digital bits inside the register. It will keep incrementing it till it reaches or it is equivalent to the input unknown voltage. So here we can see when VAX exceeds VA by at least an amount equal to VT, that is the threshold voltage, the comparator output will go low and stops the process of modifying the number inside the register. So at this point, VAX, which is the output of the digital to analog converter, is a very close approximation to VA. So the digital number that was inside the register for which the conversion stopped, that is, which is the digital equivalent of Vx, is also the approximate digital equivalent of Va with the resolution and the accuracy of the system, that is within the resolution and the accuracy of the system. So now once that happens, the control logic now activates the end of conversion signal. Now why is the end of conversion signal very essential? Now see, suppose this particular converter is connected in a computing system comprising of many say microcontrollers or microprocessors. Those things are high speed in nature compared to analog to digital converters. Analog to digital converter circuits are very slow. So if a microprocessing unit is now monitoring the conversion of ADC, then it will be a wastage of the resource of the microprocessor, because the microprocessor will sit idle for a pretty long amount of time, which is the wastage of the resource of the microprocessor. So what the microprocessor can do is it can initiate the conversion process and start working of its own functions, or handling the other resources. And when the conversion is over, this particular circuit will generate an end of conversion, which then will be sampled by the microprocessing system or the microcomputing systems, and then it will be able to understand that the ADC has already completed the conversion, and then it will take the digital output through its data bus and start working on it. So it is always the slow devices like ADC always have an end of conversion to let the other devices know that the conversion has been completed. So this is what is the basic of analog to digital converter, and these are the reference book from where you can get a bit of knowledge regarding the analog to digital converters. So let's have the next video on different types of ADCs. The next video will be on flash type ADC, and then we will see the successive approximation resistor type ADCs. Thank you. Thank you very much for watching this video.